Okay, so we are here again. So what we're doing is the loss function stuff. I wanted to actually plot. I wanted to actually print that to make sure that what I'm getting here makes sense. Why true? No, that's not what I want. I want y true index. I want basically the y true index. I want to print the these and then the lock. Exactly. I want to do these. I want to basically go here and say Python train pi, because that's supposed to print then. Yeah. Okay. Yeah. Okay. So this is basically a 0, right? So. Oh, that's wrong. Wait a second. Is it just all the time 0? Why true? Because these are all very small numbers. I don't know why. So they all look like zeros. So it almost looks like, because there might be something wrong here as well, right? So it almost looks like either it's not working or like y true. So the loss function is the y distribution, which is basically all zeros, and then this equals 1. That's y true. And y, so let me just print that. Print y, print y. So okay, no, okay, so that is an actual index. So y, and then that is an actual index, and y dist so can I print y dist shape, and then yeah, okay, but yeah, that is just supposed to be maybe that's not the right thing to do. So y, and then that is basically the shape. Okay. So that sets these to 1. Why isn't print like a is argmax? So true index. why am I giving the true, like, why true is not even used here? So why I don't just, I'm not so sure argmax is doing what it's supposed to do, and anyway the y true index is something that I can already give it here. So y true index, you know what I mean? Like the y true index is already what I can give this. I can just give not the y distribution, but I can actually give it, I can actually give it y, right? The thing is, in terms of in backwards, I do need the y distribution, right? Because I will need to do that. I think I will need to use that for, but I can already give it not y, but I can already, yeah, I can give it y, because y is like the index of, y is going to be the true index and okay, so now at least the index is something, although maybe that was already correct because I couldn't see that. I think that was the wrong thing to do anyway. What is the value of that? So that is the index. So this should just be index, true index, true index, true index, and then this should be, okay, so predicted, yeah. Of true index, right? Okay, so that's what makes sense, that it's almost 0. Yeah, this means it didn't predict that class, right? No, I think that is fine. I think that is correct. Those things are effectively 0. Okay, and then there's the, no, okay, that is all good. This is all good. I guess so. But I don't need to do the Rmax thing because I can just give it the whole thing directly. But it was working well. Okay. Now we need to get into, so what we need to do is we need to get into the actual derivative. That's what's gonna be complicated. How do we approach these? How do we approach these? So explain this code. So it's the number of training examples in the input data. Wait a second. Shape, y shape is the number of training examples in the input data. That is not correct. That is not correct. It's used later for something, but that is definitely not correct. That is the number of classes that we're trying to predict. Then is the derivative of the loss function with respect to the logits. It calculates the difference between the predicted logits and the true labels. Okay. This is where I don't think it's correct. this is what I don't think it's correct. How should I debug these? Essentially, this is just an array, right? So if I guess, can I so print logits print y. And I'll just do a couple of runs. Okay, so essentially you've got logits, right? And y. Okay, so logits, it's very interesting because it's actually not all zeros. And some of this stuff is negative. So logits, the self logits are really, this is really the predicted output before softmax. That's the first question. Do you really do this with the logits, or do you do this like after the softmax, right? Because self dot props, you know, like if I print if I do that, oh, what was that? So if I do these, basically the logits are like that, and then the probabilities are just like these, right? So mostly zeros, right? So what is the softmax function doing? With the corresponding value. The function first applies the exponential function to each input value, subtracts the maximum value, normalizes the resulting array. Some probability sum to 1. Softmax. Maybe it's not correctly implemented. X. And P sum. So if I here, if I print the sum of sum of probs, okay, and if I let it run, I think we've got to check all these things because, as I said, this all works end to end, but it's not really, it's definitely not doing, okay. Oh yeah, but it's like it's almost there. So it sums the probabilities to 0.1. Can we plot one of these? Let me just plot one of these, and can we so plot some props. Can you do something like that? I don't have here. So let's do this. It's a bit hacky, but so we will add these, and then basically can I just say ghostwriter plot props basically. So there it is here. Just this. So is there basically a way to stop like train, I guess? Can I just you know what I mean? I don't wanna whatever, like I just wanna stop it, like just wanna try one thing and then stop it. See if it actually plots anything. Could it just be that it stops the does this like stop? I just wanted to plot these. What is the fastest way to do that? Output. It's probably just plotting too many. Could it just be? Can we just can we just do one run? I just want to see an example of one. If you know what I mean. To be honest, I don't know what I'm trying to see. I'm trying to see what I want to see. I want to see if these probabilities are. Let's not plot anything. Let's just do. I want to see how many of these probabilities are like higher than 0.5, for example. So, for example, so basically, code actions. No. Generic code. Count how many self props are higher than 0.5. Okay, let's see. It's a bit clunky. Self props. Some probabilities. The truth. Can I the console? that's not gonna. I think that's just. I think that's the problem, right? Self props. No. Oh, okay, that's interesting. Can you do something like that? It does not give you the number. Oh, that's not what I meant. That's what I want to do. What am I trying? I don't know. What am I trying to check though? Really? I mean, there is one number with higher probability than half. What happens if I do this? So there's clearly an element that's higher than, yeah, it's higher. 0, 1, 1. Okay, good enough. But I mean, what is it that we're trying to do? So what is it that we're trying to do? What is it that we're trying to do? We have, so, okay, so we have the probabilities, but now the question is like, so how do we do these? How do we compute that with respect to, so our loss function, right? Our loss function is basically the negative logarithm, right? How is that like? And there's the negative logarithm between of the predicted things, right? So it's not logic, if anything, it's props, but still. How do you do that? How do you calculate? This is where we might have to just go a bit into the mathy part, right? So because the concept of a derivative of a function is easy to understand, but here we're doing sort of the derivative of a probability distribution. So how do you calculate the derivative of the loss function? Of the loss function, the derivative of the loss, because essentially the loss function, if you have to basically picture the loss function. Respect to the logits. What is the loss function, right? The loss function is a function that given an input, it tells you what the law, like it gives you a loss, right? So it's actually it's actually just a one-dimensional to the input and output, but then if you think about how that loss function really looks like, the loss function, like how would you plot the loss function, right? So what's the input of the loss function? It's basically all the predictions across your training set. You know what I mean? Like you like if we really wanted to plot the loss function on a given with respect to a given like state of the model, right? maybe it's not the right way to think about it, but I'm trying to understand why does a derivative make sense here and how would you implement that, right? So I have, like, my input is basically sort of, I've got a model, right, which is just probably random at the beginning. If I run through basically I take in my training set, I just do forward passes, calculate the loss of each of these passes, and this is how you plot the loss function, right? And what you want to do is you want to calculate the you wanna calculate what do you want to do? You want to calculate the derivative of the loss function with respect to the model, right? With respect to the actual, like, with respect to this W2 thing, or A1 or whatever it is, right? So with respect to that, to the model itself. Because then you wanna essentially, this derivative will tell you, what will this derivative tell you? This derivative will tell you, yeah, that's the wrong way of thinking about it. The way you define, is that called the domain of the function? Like the way you define the input space of the function is not, is all the possible configurations, is like basically all the possible like matrices of your model, and then a given, like, let's just make the simplification that the model is one matrix, right? So given all the possible values of this matrix, then kind of each specific one, because this is multi-dimensional, right? Like it's that's kind of what makes it difficult to think about. But you wanna, in an abstract way, you just wanna take the derivatives so that you can, because you can imagine this has like, let's imagine it's very simple. Let's imagine that it's not a matrix. It's just like your model is just a number, right? Just an integer. And so you wanna basically, that integer will give you sort of a loss. It will have a value for the loss function, and then you want to make the derivative so that you know how you have to change that model in order. So you essentially you want to know the direction of, descent, of like, of how, in what direction that function is going down, the loss function, because you want the loss function to go down. And these will essentially, but how do you translate from that derivative to the change in the input that you have to make, right? Because obviously you get these dz2 here, and this dz2 is basically then packaged into like an update of this stuff, and then at some point, yeah, so there is kind of an update on these matrices, right? Like this is wrong 100%. I'm sure this is wrong, right? But how to implement it correctly? So how to implement it back? Like how? So given this, I'm not so sure Ghostwriter is gonna be able to help me. Like I don't know how to even use Ghostwriter here, right? So I might just actually have to try and use something else. But let's give it a try. Like so there's X. Why is X even needed, right? How do you implement? Well, let's just trash it. Let's clean it up. So how do you implement the backwards pass on a neural network our loss function is the negative log. And essentially that model just has, so the model has W, like it has W1 and B1. The model is a little whatever. I don't really know if that makes sense as well. How is that organized? Because it's got a W matrix, and then you calculate a Z1, and then you do the tangent these, and then you use these times these, and there's another bias in here, so there are two biases. So I'm not so sure how you really implement that, like whether that makes sense or not, right? But yeah, the problem is it stays in this implementation. Let's just explain code, edit code, repli docs. No. So in order to implement the backward pass on neural network, you need to calculate the gradients of the weights, exactly, the gradients of the weights and biases with respect to the loss. In this case, the loss function is negative log, so you will need to compute the derivative of the negative log with respect to the weights and biases. Here's a general outline of how the backward pass can be implemented. Calculate the derivatives of the negative log with respect to the logits. But I'm not so sure if this is with respect to the logits though. Calculate the derivative of the logits with respect to the weights and biases of the last layer. You backpropagate the derivative through the last layer using these derivatives to obtain the derivative of the loss. Calculate the derivative update wow, how do, this is going to be hard. This is going to be hard, but actually that's what we like. This is definitely going to be hard. So how, we should try to understand obviously the different layers, right? So my idea here is that probably what we should be doing is we've got different elements in the neural network, different matrices, different steps. There's the first layer, there's the sort of the hidden layer, and there's like the biases, right? So you want to calculate the derivative. You want to do these. I guess you want to do these. You want to date each of these different components separately, which is exactly what's happening here. I think that kind of makes sense, right? So the idea of this learning rate, that's kind of how far down we go, that update. And then there's DW2, DB2, DW1. So I think the structure here makes sense. There's an individual update for each component of the neural network. So we just need to understand how to calculate each of these separate components. So here, yeah, exactly. So basically now it's just about how to calculate these, right? These different these different components. So let's start with DW2. What is DW2, right? What is W2 in the first place? Hidden size, output size. So that is the outest layer. That's the one that makes the transformation to the output. And so what it's doing here is what the fuck? Why? What is this doing? So A1 transpose, reshape A1, and then these are two. I don't know, what is these? What is these? so dz2, here's just a reshape. So dz2 represents the difference on this thing, on sort of the difference in probabilities, right? So the probabilities that we have minus these. Now, these kind of, from a first principles thinking perspective, kind of make sense if you think about the cases where you've got a probability distribution and there's one element that is 1, right? And so if what you're predicting is the same, then these operations should essentially give you all zeros, right? Because you're minusing every element, so it should give you all zeros, which in turn and then should translate to no change happening, because you found the thing, right? So but if instead it says no, this is the probability, it's this one is like where can I you find whatever, so just notes, like if it's like 0 0 0 0 and then there's like a 1 here, so this is basically the true one, and then the predicted one is basically what is then the minus going to be. Okay, so that's what's not, it's like true minus predicted is just going to be like -1, right? And then like a 1, and then essentially something like that, right? Is this really the derivative? Like how am I going to use these? What is that? Because that's what it's happening here. So and then what we're just saying is we're reshaping these, and how. So we're doing the transpose of A1. Why? Nobody knows what A1 really is. What is A1? But anyway, we're doing a multiplication of A1 transpose with these. And that's DW2? DW2. W2 is the hidden size, blah blah blah, and then where is DW2 updated? It's just randomly here down, and then the YA1 is the tangent on. It's got nothing to do with these. Should be Z2, shouldn't it? Okay, it's A1 as well that's involved in there. I don't know what A1 is. I should probably understand a bit better what that structure is before I make any statements in here, right? But it's essentially it's an A1 transpose DZ2. So we're multiplying, we're reshaping these. Essentially, we are doing a dot matrix, a dot product here. Should be, there'll be a nice way to visualize that. But and on top of these, it's somehow normalized. Oh, I don't know what this component here is. Y 1 divided by m. And then there's and that's it, right? And that's DW2, and that's the change that you're making in here. I want to see actually what are these values, and probably we'll just leave it here, but I want to see what are these values in each iteration. I think I'm not so sure that's ideal or that's perfect, because essentially there's a negative where the prediction should have happened, but then there's a positive where you know what I mean, like that's still there somehow, this one. I don't know what the effect of this is. So what if we go here and say, okay, so so print tw2 print, nice. It knows. It's nice because at least I do feel like it knows what I mean, what I want. Yeah. Okay. Oh, but I wanted that. Okay, cool. Print changes. Let's see what happens. Are these things somehow like significant, right? Of course, those are matrices, of course, but look at these. So it's still pretty much zeros. It's funny. This one is also still pretty much zeros, right? It's all exponentials. This is where something's not right. Definitely that's kind of where the problem is. There's literally almost no change. There's literally almost no change in these elements. Is there any element in the matrix, you know what I mean, that is bigger? Like that's almost zero. Can I add, like, can I add to add in a tensor? Because I'm sure that that's just not. I think NP-sum could work, yeah. And I'll leave it here. But you know what I mean? Like I think I've identified what the problem is. I mean, I was sure this was here, right? But it's still. It's almost zero. You see, like these changes, like they're almost zero. They're always zero, literally always zero. Because those are very small values, like those exponentials. Even these this is just zero. Okay, so that's the problem. They're all zeros, basically. I need to fix that. So they're basically zeros, and that's why this thing is just going like it's just doing nothing. Essentially, it's not changing almost the metrics at all. So it's so in every pass you just get something that's like still random. No changes at all. But I think so. What is one thing? So to understand why this is not like doing anything here, right? So it's really just doing zeros all the time, and then it will be good to understand the architecture a bit more, because I just like copy pasted that code from Ghostwriter, but I don't really understand where all these matrices are really coming from. See you next time.